unless you go faster than the speed of light, it doesn't matter.
Well, they say information cannot go faster than the speed of light, but gossip can, because it has no information content. It's not restricted by that. Sorry?
Depends on which theories you read.
It's all according to Einstein anyway, and he had made mistakes before. Like quantum physics is voodoo.
Quantum physics is voodoo.
Yes.
It's crazy.
It's crazy, but it works.
Like sometimes when you have effect coming before cause, and
Or when you observe it, it's different.
yes.
Yep. All right, let's go ahead and get started. I'll start with something that most of you do not need anymore because you're already here. It's called a Career GPS. It is an event for middle school and high school students for the most part. So if you know someone who's a little bit younger, maybe your brother, sister, someone who's in that age group, make sure that they either participate, and most schools will arrange field trips to go to the Career GPS. There will be 6,000 students, going through the booths, on those 2 particular days. Just look up Career GPS, look up the schedule, and it's really quite interesting. The way they do this, and I think some students in this class may benefit from this too, is they use the concept of a Holland code to help people, to guide them to different types of professions. So the Holland code, it basically says, it describes people in, separate people into these 6 categories. Realistic people, who are the doers, the people who actually like to work on stuff. I can give you, typical examples, people who like to work by themselves, alone, physical activities, outdoor stuff. Those would be the R type, realistic. The second one will be investigative. Most of you are probably in that category because you're in a class like this, or you are in a program that requires a class like this. You're most likely in the investigative type of category. Artistic means, artistic people. They like art, they like to express, and they have a lot to express. Then you have social people, who are more people-oriented than anything else. Then you have enterprising people, who are persuaders. They are the people who lead, they're the people who organize, and the world becomes a much more dangerous place with those people around. Sometimes better, but most of the time more dangerous. And then you have the organizers, the people who keep everything going. They're detail-oriented, they are task-oriented, they are best for operation type of work. In other words, you tell them what to do, here's the manual, they will follow it to the teeth. Okay, so they get things done, they pay attention to details. So anyway, read up on this one and also Career GPS if you know someone who can benefit from navigating through all the possibilities and find out what is best for them. Okay, so that's a little spiel. And we are done with that. And now back to the really boring stuff, like your next homework assignment, the pre and post condition assignment. Just like the other one, you download the document. So you right click, download the document, and then open the document after you download it. And this one is not a spreadsheet. This one is a document. It's a word processing document, because all you have to do is to finish your derivations right at that point. So you have to download the file and work in the file, and then save it, turn it back into me, and you're done. Are there any questions about this homework assignment? It's basically the same stuff that we have talked about for the past few weeks. In this case, we have a conditional statement. Inside the conditional statement, we have these assignment statements. And I give you the precondition of line 1. It is x is less than y, and 2 times x is greater than or equal to z. And then from there, you have to derive post 5. And I want you guys to do it step by step, just like the way I did it in class. Are there any questions about this? No questions? I think, I uploaded video screen recordings for those particular days, so you can check back on the video. If you want me to upload a file, because I did not upload a file on those particular days, let me know and I'll upload the files too. All the text files that I type in class, they're all saved. I have not uploaded some of those to Moodle, but if you want to upload those to Moodle, I can upload them. Yep. That's a good one. Can you remind me to do that?
Yes.
Can you tell me which day? Because I have a lot of days.
I'll go back to my notes and let you know.
Okay, let me know which specific date or dates, I can upload just those particular dates.
Put them in a Dropbox. Give us all
Yeah, actually I can install a Dropbox plugin, so whatever I save, appears in Dropbox like right away.
Grab them if we want them.
Yep. Change. Modify. All right. So now we are back to our algorithm from last time. Do you guys still remember, how to factor, how to find a prime factor of a number? Kind of? Okay. So I'm going to open up that particular file first, and then we'll go from there. Because that program works, but it's not optimal yet. We can make it better. Nope, that's not it. So let's see, where is here? And let me make a folder to save today's file. So we'll save as. It doesn't let me create new folders. I know. I've been looking at that.
Too many.
Hmm?
You have too many folders.
No, that's not it.
Never have to.
Okay, now that I have that folder, I can click save. All right. Okay, do you guys still remember these two pseudocode? This is the preferred version, and this is the version that will work the same way, but it's not preferred because in order to determine what is the first prime number I will test, I have to look at the first statement, which is f gets 1, and also the body of the loop, which is f gets f plus 1. In other words, I have to combine this statement and this statement, because it's a post-checking loop, in order to find out what is the first prime number I will use in this case. And that makes it a less obvious solution compared to the first one, because the first one has an initialization, f gets 2, and immediately on the following line, it has the test. So by the time I get to the second line, I know exactly what is the initial value of f when I test whether f is a prime number or a prime factor of n in this case. Are we doing okay so far with this example? Okay. And you can trace it too. You can go through a trace just to make sure that you understand how the algorithm works. But this doesn't have the optimization that we were talking about on Tuesday. Remember on Tuesday I said you only have to test up to the square root of n and not anywhere beyond that. So we want to kind of integrate that into the algorithm. So we'll just go ahead and continue this to optimize the algorithm so it stops when f times f is greater than or equal to n. We'll do the following. So we'll just go ahead and copy and paste portions of the code. And can someone kind of suggest what we should do here? In other words, I just want to know, I know this condition still needs to be here, because when I find a prime factor, I should exit right away, whether I'm at the square root or not. But in addition to this condition, I probably have another condition here, and somehow I have to relate the two conditions. I can choose and or. Which one should I use? And, very good. Why does it make sense intuitively to use and?
Because you want both things
Because
to be true.
Exactly, you want both to be true so that it's easier to get out. It's easier for the entire thing to be false so you can get out earlier. Does that make sense? Because we want our optimization to get out of the loop earlier, quicker. Okay? If I use an or, it will just, in the worst case, it will be the same, but it can also make it even longer, go through more iterations. If I use and, that means if this condition is false, I will get out anyway. But if I use an and here, that also means the second condition also has to be right, has to be true to stay in the loop. The question now is, what should I use for the second condition? I actually gave you a really good hint when I describe, to optimize the algorithm so it stops when blah blah blah. So this is the exit condition, right? The loop will stop when this happens. So in order to stay in the loop, what do I need? The flip side of that, right? So we want f times f to be less than n to stay in the loop. As soon as f times f is greater than or equal to n, I'm getting out of the loop. This only has one problem, because when it does exit the loop, f is not n yet. Okay, if n is a prime number, this will let me get out of the loop when f times f is greater than or equal to n. So that means, okay, let me just illustrate the problem that I have using a trace, and then we'll go ahead and fix it. So I'm going to use a spreadsheet and write the algorithm here. It's short enough, I can just write the whole thing. While n mod f is not 0, and f times f is less than n, do the following: f gets f plus 2, f plus 1, and while, yep.
Oh, sorry, I wasn't here last class week. What is mod?
Mod is the remainder of a division. All right, so we'll go ahead and trace this. Let me save the file first. And we'll call this find factor 1. Okay, so let's go ahead and open a new window. We need comments because we have a condition to evaluate. We need line number. We have 2 variables, even though only one is changing in this case. And the precondition has to give you a specific value of n, because otherwise we cannot determine what is a prime factor of a unknown number. So in this case, n has to be a number. And I would pick a prime number like 7, because the problem will only happen when n itself is a prime number. When n is a composite number that actually has prime factors other than itself, it's not going to show up. So we will have n initialized to 7, and f does not need any initial value. So we'll just specify and say that we don't know it because we don't need to know it in this case. And we'll go ahead and start tracing the algorithm. All right, so we have line 1, and after line 1, f has a value of 2. Not really surprising. Go to line 2. We need a little bit more space for comments because we have a long condition to evaluate. All right. What is n mod f in this case? N is 7. F is 2. What is the remainder of 7 divided by 2? The remainder is 1. 1 is different from 0 is true. Okay. So this condition is true. So that means I have a second chance to make it false. F is 2. 2 times 2 is 4. 4 is less than 7 is true, right? So we have true and true in this case. That means the conjunction itself is also true. Where do we go next? The condition of a while loop or pre-checking loop is true, so where do we go? We go to line 3, we go to the body of the loop. We add 1 to f, f goes from 2 to 3. We go back to line 2, because this is a loop, it's not a conditional statement. And then we have to reevaluate. N is 7, f is 3, 7 divided by 3 has a remainder of 1. 1 is different from 0 is true. And then now we have to look at the second condition. 3 times 3 is 9. 9 is less than 7 is false. So the conjunction is false because at least one side is false. And then where do we go? Post. We go to post. We're done. Well, that doesn't really work, does it? Because the algorithm is supposed to find a prime factor f of n. If you look at f, it is a prime number this time, but is it a factor of 7? It's not a factor of 7. So that means we probably need something in addition to this to finish the program. Okay? Well, the problem only happens when f times f is, well, there are two ways to look at this. The problem only happens when f times f is greater than or is greater than n. This is the only time I need to take care of this with a conditional statement. Why do you think that's the case? Well, let's think about when we get out of the loop, what is the relationship between f times f and n?
In specific cases, greater than.
Okay, there are three cases. Okay, let me. Okay, I will show you the long version first, and then I'll kind of optimize the program. The second case is what if f times f equals n, and then the last one, I'm just going to be very redundant here. There's nothing wrong with this code. It's just extremely redundant, and I will later on optimize it so it's not redundant. What does it mean when f times f is greater than n, and I got out of the loop? What is that telling you about n? I have tested all the potential factors up to the square root of n already, and yet I got out of the loop not because of the first reason, which is n mod f is different from 0, but because of the second reason, f times f is less than n. It's not less than n, excuse me. So what is that telling you about n? Does n have any factor other than itself? No, because if it had, I would have found it and exited because of the other reason. So in this case, I have to say f gets n because n is a prime number itself, and therefore it is its own prime factor. Is that okay? Is that reasoning okay? Okay. What if f times f is exactly n? Do I need to do anything about f? In other words, in this case, if f times f is n, is f a factor of n? Quite obvious, right? So in this case, f is fine. We can just say something like this to basically emphasize and say there's nothing we have to do. What if f times f is less than n? Is it possible to exit the loop even though f times f is less than n? Absolutely, because there's a conjunction in the condition. This is a conjunction, which means if at least one side of the conjunction is false, we are getting out of the loop. So that means if this is false, we can still get out of the loop even though f times f is less than n. Is that right? Yep.
So n is constant, right?
N does not change in this code, correct. So in this case, if I got out of the loop, f times f is still less than n. That means the only reason I got out of the loop is n mod f is different from 0 is false. What is the other way to say that n mod f is different from 0 is false? N mod f is 0. What does that imply?
F is a factor of n.
F is a factor of n. So that means f is fine. There's nothing we have to do with f in this case too. So we'll just kind of do something, not very smart, but not wrong nonetheless. Are we doing okay so far with exploring the three possible outcome or the three possible relationships between f times f and n, and explain why in each case we know what to do with f? But two branches out of these three are not really useful. If you look at this branch and also this branch, neither is doing anything useful because I'm just taking the value of f and put it back to itself because I'm just saying f is fine. There's nothing we have to do to f. So we don't really need those branches, do we? Well, if we don't need those branches, we'll just go ahead and say, okay, we don't need to check for those conditions and we don't need to perform those branches. We'll just go ahead and remove these things. But if we don't have those lines, we can make the program slightly more compact. So we will delete those rows, and that is the final version. You just have to catch that one case when n is a prime number, then you have to make sure that you update f so that f is the prime number itself. So to fix our trace, because now we made our program a little bit longer, we'll go back to our trace, and then we'll just go and say, okay, we don't have a post yet at this point because the program has not finished. And instead of just overwriting this, I'm going to use format character. This is there we go. I'm going to use sprite out to represent that since we changed the algorithm, we are not ending here yet. And we move on to line 5 because there is a line 5 now. Line 5 has to evaluate the condition, which is f times f is greater than n. Is that true or not?
It's true.
Well, let's take a look. Because f is 3, 3 times 3 is 9, n is 7, 9 is greater than 7 is true. Then where do we go? This is a conditional statement. We go to line 6. Line 6 says it'll copy the value of n, so that f has the same value. So f now has the same value of 7. And then we are at post. So this completes the algorithm because now f truly reflects a prime factor of n. Are there any questions about this last step here to optimize the algorithm? Is that okay? All right. So let me save this. And at this point, okay, I'll just add it to my text file too, just so that it is complete. F times f is greater than n. F gets the value of n, and if. All right. So here comes the next question. If you go all the way back to the overall algorithm, which is this one here, the highlighted algorithm is the overall algorithm to find and display all prime factors of n. I'm probably missing one line here. I'll just go ahead and add it at this point because I have to print it out so that someone can see the result for f here. The question is, should I take the algorithm that I just finished and replace this one single line with that chunk of code, or should I leave this one the way it is here and then just say, oh, if you want to know how to find a prime factor f of n, refer to this other algorithm. Which way should I do it?
Refer.
Refer, very good. Why? It has to do with exactly. Well, it's the whole idea of this particular module is top-down design. We don't want to clutter up the algorithm unnecessarily. So if you can simplify the description of how you want to do something, that's how we want to do it. Are there any questions about the concept of top-down design or the algorithms in this case to find all prime factors and to find a single prime factor of a number? No questions? Okay. Later on, we'll talk about subroutines, which is a mechanism to make this happen. Because right now we have a big question in our mind is, well, we have a description here to state what we need to do, and then later on we have an algorithm here to show us how to finish, how to get it done. So how do we associate this description with the actual detail of implementing what we need to do? Right now we don't have a mechanism to do it, but when we get to subroutines, then we will have a mechanism to deal with that. Any questions about the concepts up to this point? No questions? If there are no questions, we are moving on in Moodle, and we are going to talk about something a little bit more interesting. Well, this is interesting too. Scratch for Debian is really interesting. because we have talked about enough control structure, basically conditional statements and loops and assignment statements, that you guys can actually start to play with Scratch and get some kind of hands-on experience with programming if you want to. This is completely optional, but I think some of you will kind of enjoy that. Have I shown you guys this before? I think I might have. Okay, but this is a good time to start with that because we have talked about all the control structures and it's. Has anyone actually done it? No. Okay. Did you like it?
Yeah, it was kind of fun.
It's really fun because you can program different sprites, and each program is running concurrently. So you can actually write a game. You can have one sprite representing a spider, the other one representing a fly, and you can either control one or the other. If you control the fly, you're trying to stay out of the spider's way, and if you control the spider, you're trying to catch the fly. The background itself, the canvas, okay, the stage itself is also scriptable, so you can change the background if you want to. It has collision detection, which means if two sprites touch each other, it will generate quote unquote an event, and you can handle that event and say, oh, okay, the spider caught the fly. And then you can keep score, you can do a lot of things. You can add sound effects. You can draw your own sprites, you can animate the spider crawling or the fly flying. It's really quite fun. It's really a lot of fun. If you have the time, this is a good way to practice what you have learned so far. Any questions about Scratch? No questions? Okay. If there are no questions about Scratch, we'll move on, and this time we'll talk about arrays. This is a whole different, new concept compared to what we have learned so far. But I would like to talk about it in a way to relate to what we already know. So we'll go ahead and go back to the text editor and talk about it. I have to find my text editor. I think I might have closed it already. So we'll go ahead and open it again. I want to open the text file of today, not on this particular thing. There we go. All right. Let me show you this algorithm and you tell me what it does. You don't have to copy this because you have seen this many, many times already. What does it do? Z is the maximum of x and y. All right, very good. We have seen this before. Let me show you another algorithm, and you should be able to recognize that as well. Seen anything like this before?
Yes.
What does it do?
It's determining what of the W, X, and Y, which one's the maximum, and updating Z.
Right, it finds the maximum of 3 variables instead of 2 and update Z so it becomes the maximum. Do you think I can generalize this and figure out how to find the maximum of 4 variables? V, W, X, Y. Yeah, we can kind of generalize this method. 5? Sure. We know the general method, right? Each condition will confirm a particular variable is the maximum because it's greater than or equal to all the other variables. And then we can just confirm that and say, oh, this is the maximum, and then get out of the conditional statement. The last one is the only one that does not require a condition, because if you have 5 variables, 4 are not the maximum. The last one has to be the maximum. Okay? And I can use this, to handle, 30,000 variables too, right? Should be. The program will be kind of tedious and long, but I should be able to do it. But there's one problem with that approach. The problem with that approach is, let's say I spend 2 days to write this pseudocode to find the maximum of 30,000 variables. Okay, 2 days is an underestimate by a bunch, but let's say I could do it because I know text editor tricks and certain replays and have a really good editor. What if my boss tells me, Tack, we're just adding one more variable. Now there are 30,001 variables. What do I have to do? Do I just add 2 lines to the program and say, I'm done? No. I have to change all 29,999 conditions, don't I? And then add 2 more lines, right? And then the next day my boss says, oh, wait, I have another variable. I have to do the same thing again. So this method works, but it's not very scalable. Okay, it's not feasible, it's not practical, it's just, it's not the way to do it. Now, without explaining how it works, what if I tell you I'll explain this later, so there's no need to copy it. I will trace it. What if I tell you that this code here is going to find the maximum of any number of variables? You can give me 10 variables, it will work. If you give me 10,000 variables, it will work. If you give me 30,001 variables, it will work too. Don't you think this is a little bit more attractive than having a program that has 60,000 lines and every time I change the number of variables, I have to make a whole lot of changes? That's why we have arrays. Okay, it's because with just variables without arrays, certain types of algorithms are very tedious to express or nearly impossible to express. But with arrays, we can generalize everything and go like, oh, this is easy to deal with. I can do it. Okay. Are there any questions so far about what the rationale of why just using plain variables is not good enough? Nobody enjoys having to edit a 60,000 line program every single time we add or delete a variable. Okay, very good. Now we have to explain what an array is and how do we use an array in an algorithm. How do we use it? An array, I'm just going to use the whiteboard. This is one of the rare locations I use a whiteboard because it's just easier that way. Okay. Before arrays, we have variables. Each variable is like a coffee mug. Okay, it has its own name. So we have a variable called W. We have a variable called X. Another one called Y. Another one called Z. So we can identify each coffee mug by its name. Is that okay? Each one is individual. It has its own quote-unquote value or state, which is basically how much liquid is inside the coffee mug. It can be empty, it can be full, it can be somewhere in between. Okay, that's how I can kind of use an analogy to a variable. The concept of an array is really easy. It basically says instead of individual coffee mugs, now we have the concept of a box of coffee mugs. Okay, so here's a box, and let's just say that this is a box of 3 coffee mugs. So now we have the concept of a container that can contain smaller items. In this case, we have a container, a box that contains 3 coffee mugs. But how do we identify the box and the items inside the box then? Because sometimes we want to refer to the entire box and say, hey, move that box over here. But sometimes we want to refer to the individual coffee mugs and say, hey, look at the second coffee mug in this box here. Tell me what is the content, how much content is in that coffee mug. So the way we do this is we give the box itself a name. I can name this box A. Okay? It doesn't matter. In this class, I just use simple variable names. But the box itself has a name. The coffee mugs do not have a name anymore. They are numbered instead. the coffee mug is numbered 0, the second one is numbered 1, and the third one is numbered 2. In other words, we do this really strange thing of counting from 0. Because most people count from 1, right? First mug, number 1, second mug, number 2, third mug, number 3. That's not how we do counting when we deal with arrays, or in general in computer science. We count from 0. Mug 0, mug 1, mug 2. The reason why we do that is not going to be apparent until you take cisp300, assembly language programming. When you take, sorry? The reason, so it won't be apparent. I'm not going to even try to explain why we count from 0, but it is the way it is, and you just have to remember when you use arrays and many other things, you're counting from 0. Are we doing okay so far with these concepts? An array is a container. In order to access individual items inside an array, you have to address it with a number and not a name. The box itself has a name, but when you want to address the content, you have to use its number, the index of that item. Are we doing okay so far? Okay. So in this case, A is the box, an item is inside, it has a name. So if I want to refer to, let's say, this item here, the second mug inside this box, the notation is A using a square bracket and a value of 1 inside the square bracket. That's the notation of specifying a particular item inside a box. The name of the box is outside of the square bracket. The number referring to the item is inside the square bracket. So you can kind of remember square bracket, box, that's kind of the symbolism. And the name is outside the box, and that's why the A is outside of the square brackets. The number refers to an item inside the box, and that's why the number is inside the square brackets. Is that okay? All right? So this seems to be pretty easy, but why is it so powerful? It seems like we're just changing our naming convention from W, X, Y to A bracket 0, A bracket 1, and A bracket 2. What makes this approach so much more flexible compared to how we do things before? Well, as it turns out, what appears between the square brackets, it doesn't have to be a specific number. It can be an expression. Okay? So whatever goes in between the square bracket here, it can be very complex. In other words, it can be I times j plus 2, the whole thing, times 3 plus k times k, blah, 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 blah. There's only one requirement. Well, I should say, there's only one requirement. There's only one requirement of this entire expression. It has to have a value, in this case, inclusively between 0 and 2. But the expression itself can be very long, can be a single constant. As long as it is valid, which is between 0 and 2 inclusively, you're fine. Are we doing okay so far? Now this is why arrays are so useful, because it gives you a mechanism that we call, in general, is called indirect access. In other words, you can specify which item you want to access using an expression. Now, we have never had this ability before. This is the first time we have anything or any mechanism that gives you the ability to choose what item you want to use by simply using an expression that returns an integer. Are we doing okay so far? There's one more notation that we have to learn before we move on to trace the algorithm that we have already written. The notation is bar A bar. Bar A bar is the number of elements or number of items inside the box. In this case, we have 3 items. The one quick way to remember what bar A bar means is, when you try to measure something, a lot of times you will see measurements like this, and that's where it comes from. Okay, it's using the 2 bars to represent the boundaries of the array. So So remember, in this class, bar A bar does not represent the absolute value. It represents the number of items inside an array. But just for this class. Are there any questions before we trace the algorithm, which is a very good way to practice everything that I just talked about? Yep.
A can represent some difficult expression like function, and how would the bar A bar work?
Bar A bar has to be like this. It has to be simple because whatever appears between the two bars has to be the name of a box. So in this case, A is the name of a box, because it doesn't make any sense if it is anything else, because the bar symbol is only used to indicate the number of items inside a box. So it has to be the name of a box inside the bars. All right, so let's go ahead and trace this algorithm and see how it gets the job done, because it seems kind of mysterious. How can one single algorithm, one size fits all basically? How does it work? So we'll go ahead and trace it, and this is also a good opportunity to actually see how an array is organized internally. So we'll go ahead and just repeat the algorithm here. I think I can remember the algorithm well enough not to refer to the notes.
I get a value of 1 first line.
Sorry?
I get a value of 1 first line.
Yeah, 0 would work too. 1 is better. It's slightly optimized. We'll go with 0 first, okay? And then I can explain why it is not really useful. Not wrong, but yet not very useful. Well, I is less than bar A bar. Do if m is less than a bracket I, then m gets a bracket I, and if I gets I equals 1, while, do you guys want me to indent it? Use the proper indentation?
Yes.
I have seen a lot of programs without indentations, and I always wonder how people can manage programming without proper indentation. There we go. Much better? A little better. Now we'll go ahead and, well, let me save the file first before I forget. And we'll call that find max n, because now it's not just 2, 3, it applies to any number. And then the trace window is also interesting on its own. We have the usual, we have comments, because we have we have 2 conditions to evaluate. Line 3 and line 4 both have conditions to evaluate. We have line number, that's a usual standard thing. We have one conventional variable, which is I. Now I, even though it appeared inside the square brackets, is really just a normal integer variable, just like all the other variables that we have seen so far. There's nothing really special about I. A, on the other hand, is a little bit special because A is an array. Now, if A is an array, it has components. The way I represent components in an array using a trace is like this. Each element gets its own column. In other words, A is a box that spans over 3 columns. Now, you don't have to do this when you do your homework assignment, but I'll do this just to emphasize the fact that A, as a single thing, spans over the columns D, E, F. But a particular element inside A, like A bracket 0, is only taking up a single column because it is only used to store a single number. Are we doing okay so far with this concept? An array is a box, it has components. Each component takes up 1 column in this case.
Question.
Yep.
Is this the continuous example for the box here?
Yeah.
So that's why you have 0, 1, 2, and if we have more, you will put more.
Yes. But you have to know the exact number of elements before you start an algorithm. Well, that statement has to do with the language that you're using. But since most people here will move on to cisp300, this is the case. You have to know the exact number of elements before you get into an algorithm. In some other languages, that's not true. Okay, so we'll give these elements particular values. So we'll say this one starts with a value of 5, This one starts with the value of 7, and this one starts with the value of 3. Now it is important to remember what is what, because we have a lot of numbers on these particular in these columns. This is the label on the coffee mug. Okay, this is coffee mug 0, coffee mug 1, coffee mug 2. This is the content inside the coffee mug. Are we clear on those numbers? Which number is which?
Are you going to be giving us?
Sorry?
Are you going to be giving us the numbers?
Yes, the numbers have to be given in this case because we're trying to find the maximum of the 3. So if any one of these is unknown, I cannot do a comparison and know the result of the comparison. I, on the other hand, does not need to start with a particular value as the precondition because we will initialize the value of I right away. Are there any questions regarding how I represent the array A in this case? Nope. Okay. Then we'll move on and talk about the algorithm itself. Line 1, simple. We initialize I, so it starts with a value of 0. Line 2, a little bit more complicated. Oh, I forgot one variable. I forgot m. So I'm going to have to insert another column for m. Sorry about that. I know you guys can just put it at the end. There's no need to make m exactly between I and A. Yep.
Can't you just put A in the element in the first row instead of putting it on the...
Yeah, you can put it anywhere. Yeah, you can. The only requirement is columns of A, they have to stay together. In other words, you cannot say A bracket 0, M, and then A bracket 1, I, and then A bracket 2. And that's because inside the computer memory, those elements are contiguous. They're right next to each other. But other than that, you can move all 3 columns together. You can move it anywhere you want. Okay, what is line 2 going to do? Well, we know we are updating m, but what is it getting?
It's the value elements.
Okay, and so it's going to update to a value of 5. Very good. Are there any questions about line 2? Why line 2 is updating variable m to a value of 5?
Why?
It's because we are referring to the value of A bracket 0. The right-hand side of the algorithm, or the assignment, is A bracket 0. This is array A, this is element 0, and it's referring to the value of 5. Yep.
What if we have more than just 5, like 5 and 6 and 7 inside?
It's a single column, so it can only have a single value.
It doesn't can have more. It can't have more than 5 right now in this case.
In this case, it has a particular value of 5.
So it's not going to change.
The algorithm does not change it.
Okay.
But it can be changed if the algorithm has an assignment with an array element on the left-hand side of an assignment. But since in this case we don't, they will stay the same value the whole time. Any other questions before we move on? Good questions. No questions? Then we'll move on to line 3. Line 3 is the first time we see the bar, A bar symbol. I has a particular value. I is 0 in this case. And we want to see whether I is less than bar A bar. What should be bar A bar in this case? What is the value of bar A bar? 3. 0 is less than 3 is? It's true. Very good. We move on to line 4. Line 4 has another condition to evaluate. M is less than A bracket I. Now this time we have to slow down, really slow down, and take a look at this particular statement. Because what you do is you first have to evaluate what is I. It's just like with square parentheses, you evaluate square brackets from the inside out. Okay, you have to evaluate the value of whatever is inside a square bracket, and then you do the indexing, and then find out which element we are talking about. Yep.
How do you get 3 for the A input, the absolute value? Why did you decide to do?
Okay, bar A bar represents the number of elements in array A. In this case, if you look at columns E, F, and G, that's the extent of array A. It has 3 items. So bar A bar evaluates to a value of 3, and I is 0, so 0 is less than 3 is true.
So you add all of them up?
No, you're counting the number of elements. You're not adding the values of the elements. You're just counting, we have 1, 2, 3 items inside the box. Okay, so the bar A bar symbol is just representing how many items do we have regardless of the values inside the box. Okay, it's just counting the number of items. But when we evaluate the expression or the condition of line 4, it's a little bit more complex, because the first thing we have to do is to find out, okay, what is I? Well, I is a variable. It has a particular value of 0 this time. So now once you know what is the value of I, then you can ask the question, what is A bracket I? Well, let's see. Look up the columns. Column E is A bracket 0, because I is 0, so you want to access A bracket 0. A bracket 0 has a value of 5. And what is M? 5. 5 is less than 5 is false. And that is why this particular iteration is useless, because how did M get its value? It's before the loop, it got a value of A bracket 0. And because I initialize I to 0 here, so I'm guaranteed that it will be comparing the same value on line 4 in the first iteration. It's not wrong, because I will not misidentify something that is not the maximum as the maximum, but this expression is guaranteed to be false, so I might as well skip this iteration and start with 1 in I instead of 0. So that's why I initialize I to 0 in the other version, but initializing it to 0 is not wrong. It's just wasting time. Okay, after line 4, where do we go? We go to line 7. Very good. Because the condition is false, we skip around the entire conditional statement, and then we go to line 7, which is the statement next to the conditional statement. How do we know that line 7 is a statement following the conditional statement? The indentation, right? The indentation tells you. Line 7 is going to do something to I, something simple. We know what it does. It's just incrementing it by 1. And then where do we go? We're at the end of the loop. Back to line 3. Okay. Back to line 3. I is now 1. Bar A bar. Does bar A bar change ever? No, because we have this in C and C++. The size of an array cannot change after the fact. You cannot make an array bigger or smaller. So once you have an array of 3 items, you cannot make it 4 items later on. Okay. The condition is still true because I is 1, bar A bar is 3, 1 is less than 3 is true. So we move on to line 4. Okay. What am I comparing this time? M is still the same. M has a value of 5. It is still referring to column D. So that's the easy part. But this is the fun part, because I has changed already. The value of I is now 1. So A bracket I is now referring to which column?
Bracket 1, which is F.
It refers to column F, which has a value of 7. This is why array indexing is so powerful, because it is the same line of code. It's line 4 just like last time, but this time, because the value of I has changed, it is now comparing M against a different element, a different column this time. So this is why arrays are so useful, because it gives you this ability. M is now compared to A bracket I. M has a value of 5 at this point. I is 1, so A bracket I refers to column F. It has a value of 7. What is the result of the comparison? Is it true or false? It's true this time. So now where do we go? The condition is true. We go to line 5. Line 5 is going to update M. And how are we updating M? It's the same thing. Yep, it gets a value of 7 because the right-hand side of the assignment refers to A bracket I. A is column E to column G. But I is 1, so we are referring to column F specifically. It has a value of 7. Are we doing okay so far? Okay. After line 5, there's nothing else to do in the conditional statement. We go to line 7 to continue. And we add 1 to I goes from 1 to 2. We go back to line 3 again. I now has a value of 2. 2 is less than 3 is still true. So now we go to line 4 again. We have M comparing to A bracket I, but remember I has changed. So instead of comparing to columns E or F, we are now comparing to column G. Because I has a value of 2, so A bracket I is referring to A bracket 2. A bracket 2 is column G, it has a value of 3. M has a value of 7 because we just updated that in the previous iteration. 7 is less than 3 is false. Okay. Then we get out of the conditional statement. We just move on to line 7. Line 7 will add 1 to I. I goes from 2 to 3. Then we go back to the beginning of the loop, which is line 3. I is now 3. Bar A bar is 3. 3 is less than 3 is false. And then we get out of the loop. There's nothing else after that. So we get to post. Do we have any questions about this trace? Go ahead.
Before you start this trace, you're confident in saying that it didn't matter if I started at 0 or 1.
Correct. It did not matter in the sense that they will come up with the same answer. The maximum will still be 7. It's not wrong to start with 0, it's just wasteful. It's wasteful because if you look at how M gets its initial value, it is on line 2. It got its initial value from A bracket 0, right? And then since I initialize I to 0, I am guaranteed that on line 4, I'll be comparing the same value against itself. And that means it's always going to be false. And if it is false, I don't really do anything. If I did anything, it's not going to do anything either because A bracket 0 is the same as M at that point. So that means the first iteration is completely useless because I'm just comparing the same value to itself. And that's why we can start with 1 to skip the first iteration. Okay. Oh, thank you. All right. So are we good with this? Let's work with something a little bit interesting. It's fun, but it's not too bad. It's not too tedious. I'm going to use another spreadsheet for this. I think I can just use a text editor for this. Let me switch back here. So I'm going to give you some conditions here. Okay, I know that A bracket 0, this is basically precondition. The precondition states that A bracket 0 has a value of, say, 2. A bracket 1 has an initial value of 0, and A bracket 2 has an initial value of 1. Okay? And this is what I want to do. That's too much. One more. There we go. Okay, so I want to evaluate this. What exactly is that? Well, first of all, is that even okay? I mean, is it legal to have something like that? Yes. Using array indexing within array indexing? How do we do this? I mean, you start with the innermost one, right? It's just like with round parentheses. You don't look at the outside one, you look at the innermost one first. Well, the innermost one is easy because it's 1. Okay, we know how to deal with 1. It's just a value of 1. Then we look at A bracket 1. What is A bracket 1? It's a value of 0. Okay, so that means this entire expression, I'm going to copy this and paste it. This part is just 0. Okay, well that we can do.
Question. Where's the 1 go though?
The 1?
Yeah.
I have to start with something.
Oh, okay.
So now we can look at this one and say, what is A bracket 0? It's a value of 2. Okay, we can deal with that. And then we look at this and ask, what is A bracket 2? 1. Back to 1 again. Okay. And what is A bracket 1? 0. A bracket 1 has a value of 0. So this entire thing actually just evaluates to 0. Are we doing okay so far? Because this is a good test to see whether people understand which part is the index and when are we referring to the value indexed by the square bracket operator. Okay. Yep.
Is it just this example? Because I mean, in the first one we said the 1 is 0. Right there, I mean, for math, you know, anything times 0 is 0. So would we have had to sub?
But this has nothing to do with multiplication.
I know, but like, it's a bracket inside a bracket still. So we just would have to do this no matter what. It's just this in this example. I mean, when you put a, like the bracket 1 or whatever, and you had 0.
Yes. You mean this part here?
I assume that the whole thing would equal 0 before you did the rest of it in that case.
Not really, because it has to do with, okay, okay, let me stop a little bit early. Okay. If I just take out one level of bracketing or indexing, the result is going to be what? Okay, that's 0. That becomes 2, and that's 1. Is that?
Yeah, I get it.
Okay. Yeah, this has no arithmetic operation. It's really just looking up an item inside the box.
Replacing the new item.
Right, using the value inside the box to specify who else we want to access in the next round. Yeah. But it's still doing the same thing. You handle the innermost square bracket first, and then you work your way out. Any other questions about array indexing at this point? If this particular example doesn't seem to be too difficult and it's fairly straightforward to you, I think you got the whole concept down, the array indexing. If not, you might want to just kind of look at this again and try to read the notes, because this is all kind of coming from the notes too. Any other questions about this? No questions? More algorithms then. More tracing, more algorithms, because that's basically how I would learn from classes to do it by examples. All right, so let's go ahead and write another algorithm, and this time we'll start with 1, and I'll initialize a bracket 0 with a particular value. Let's pick 1 in this case. And we'll say while I is less than bar a bar, do the following. And this time I will say a bracket I gets 2 times a bracket I minus 1. Now, this requires a little bit of explaining, but it's really not much difficult than the previous one. Are we ready to move on? Okay. All right, so let's go ahead and try to trace this algorithm. We have comments. Line number. We only have one regular variable I in this case. And we have an array A. Let's just say that we have 3 items in A, just like last time. So A bracket 0, bracket 1, bracket 2. And this time I don't need to know anything before the algorithm starts, because that's the whole point of the algorithm, is to populate the entire array. So everything can start with an unknown value as a precondition. All right. So we start with line 1. Line 1 starts with putting a value of 1 into I, so I starts with 1. Line 2 specifically puts a value into A bracket 0. A bracket 0 is column D, so column D now has a value of 1. Just to be consistent with what I did before, I'm going to merge these 3 columns into 1. Now we are at line 3. We know how to deal with this already. We dealt with it last time. I has a value of 1. bar A bar is the same as last time. We have 3 items in the array. 1 is less than 3 is true. We go into the array, we go into the loop, go to line 4. Here's the fun part. How do we deal with this? This is too complicated. Well, remember what I said? You deal with a square bracket, just like how you deal with parentheses. You work with the inside first, and then you use it for the indexing operation. So in this case, because you see that I minus 1, the entire expression I minus 1 is inside the square bracket, so that's what you need to start with, is to evaluate what is I minus 1. You look at the trace, I has a value of 1 at this point. 1 minus 1 is 0. So that means this is actually just referring to A bracket 0. A bracket 0 has a value of 1. 2 times 1 is 2. Okay, so the right-hand side of line 4 is just 2. What do we do with that? We want to store that into A bracket I. I is 1, so A bracket I refers to A bracket 1. A bracket 1 is column E, and column E is now updated to a value of 2. Are we doing okay so far?
Yes.
Because this one single line, line 4, is using array indexing on the right-hand side and also on the left-hand side of the same assignment statement. So what it is really telling you is when you refer to a single item inside an array like this, and that item is a number, it can go anywhere where a conventional variable can go. It can appear on the left-hand side of an assignment statement. It can appear on the right-hand side of an assignment statement. Awesome. Are we doing okay so far with line 4? Because after this, the second iteration is just going to be boring. Line 5 adds 1 to I. I goes from 1 to 2. We go back to line 3. I is 2. 2 is less than 3 is still true. Go to line 4. What is line 4 doing? Let's focus on the right-hand side first. Okay, we have to look into the inner part of the square bracket. I now has a value of 2. 2 minus 1 is 1. So A bracket I minus 1, close bracket, is really referring to A bracket 1. A bracket 1 is column E. It has a value of 2. We multiply that by 2. It becomes 4. We store 4 into A bracket I. I has a value of 2, so we are actually storing the value into A bracket 2, which is column F. So column F now has a value of 4. We go to line 5. I is incremented again, so it becomes 3. We go back to line 3. I is 3 already. 3 is less than 3 is false. We get out of the loop, and we are done. So if I make this array any bigger, A bracket I is basically 2 to the power of I, because it's going to double every single time. Are we doing okay so far with this?
2 to the power of I at the time that I is equal to.
Correct. Right. Well, the index of an element is the power of 2. Is the power of the value that is being stored there, using 2 as a base. All right. So we'll go ahead and save this file. And I'll just say powers of 2. Because that's what we're doing. Okay. Yep.
My only question is, you said lists can be changed.
The size of the array cannot be changed.
Well, okay. I was just curious because you said the last one, you said you couldn't start in the algorithm if the list didn't have any, well, the array didn't have any value. So I was just under the impression, well, I know for a fact that lists can be changed, so that's just why.
Okay. Okay, that's a good question. Let's go ahead and explore
well, list, I
that.
keep saying list, areas. List is areas.
A list is not an array.
Well, list. I'm just thinking about it because what you're doing is so similar to lists. So.
It is very similar. You're talking about a list in a scripting language like Perl or PHP. Is that right?
Yeah.
Which particular language are you?
Python.
Python? Same thing. Okay. So that's a good question.
But I was just I didn't want to refer to that, but basically I was just curious because in the last one you said couldn't change. Well, they had to have values before you started the algorithm.
Right.
But in this one, you didn't have any values when you started the algorithm.
That is correct. Well, it's not like it doesn't have any value. It's just that I do not know what it is, and I do not care in this case. Yep.
I'm familiar with Python also, but to get a similar effect, would you just create a new array with the added values from the previous one?
In C, you will have to go through that trouble. Okay. What? Okay, I'll call this out of bound. Okay, which is really already telling you what the program is going to do, and this is not uncommon. Not an uncommon mistake people do. Instead of using less than, it is less than or equal to. Okay, so we'll go ahead and see what happens in this program. I'm not going to redo the entire trace because for the most part it's really the same program, except we are not going to stop here. And I do have to change all of these to refer to I is less than or equal to. So nothing is changed except for this line here, because at this point I has a value of 3, bar A bar is also 3, 3 is less than or equal to 3 is still true. Okay? But the problem is not going to happen on line 3, even though it's the cause or the source of the problem. It's not the symptom. The symptom happens on line 4. If you look at line 4, the right hand side is okay. We can still deal with the right hand side. I has a value of 3 at this point. 3 minus 1 is 2. A bracket 2 is column F. Column F now has a specific value of 4. 2 times 4 is 8. In other words, the right hand side of line 4 is fine. It evaluates to a value of 8. The question is, what am I going to do with the left hand side? That is the question. So I'm going to write here and just say, what are we doing with the left-hand side? Okay. The question is what we are going to do with the left-hand side, because what is the left-hand side referring to? What is I?
3.
I is 3, and A bracket 3 is where we want to store the result. Where is A bracket 3?
Don't worry.
Now it depends on what you're talking about, right? Are we talking about Python? Are we talking about C and C++? Or are we talking about Visual Basic? Because they all respond differently. Okay, so let's talk about Visual Basic first, because it gives you the most straightforward response. Okay, so I'll just write down here. VB will give you a runtime error, which is the best answer of the 3. Do you know what that means? A dialog box will pop up on your screen, and it will say array out of bound or something like that, or index out of bound, because you're trying to access an element in an array that does not exist. The box only has 3 items. You're trying to access the 4th one. Visual Basic says you cannot do it. The coffee mug does not exist in this particular box. Runtime error. Hey, there's a problem here. It will even tell you on which line the problem is, so you can fix it, or if you can get close to the fix itself. That's what Visual Basic is going to do. C and C++ and Java will give you corrupt something. Okay? The way C and C++ and I think Java is the same way too, the way they work, maybe not Java, I'm not 100% sure about Java.
It just creates
Yeah, no, it does not create. It just says, okay, now this is a box on the shelf, right? Because you can look at the memory organization of everything as just one contiguous area. So on this shelf, you have other things. So maybe the next coffee mug is the actual variable I. Let's not use X here. So we'll go ahead and use a variable that we have already used in the program, I. Okay, I is a single variable. It's not a part of an array, so it's just a coffee mug with a name. So what happens here with C and C++ is when you try to access the 4th coffee mug inside the box here, it will just go counting like what we do. It's like, 0, 1, 2. Oh, this has to be number 3 then. Okay? It doesn't care whether this coffee mug is in the box or not. It's just the fourth counting from the beginning of the box. It doesn't know where the box ends. That's the problem. In C and C++, it doesn't know how big the box is. It just knows where the box begins. Okay?
That's the problem.
So this coffee mug here, as far as this program is concerned, has two ways to access it, because this coffee mug, unfortunately, is also known as A bracket 3. Or A bracket 3 will try to access the same location, which is going to be a problem, isn't it? Because this is also I, so that means it will change the value of I, but not the way I arranged it in the spreadsheet, but if this is actually how it is arranged, it would have changed something else, something that you did not intend. What if this location that I use coffee mug I here to represent is actually a variable that you do not access until 200 lines later? Then by the time your program bombs, which is 200 lines later, you'll be too far away from the source of the problem. And it will take you a lot of time to track down, who changed this variable? I didn't change it, since the beginning of this code. But how come by the time I get there, its value is changed? It's because of accessing an element out of bound. Okay, this is a big problem, and somebody in this class will get bitten by this problem multiple times in CISP360. Mark my words. I personally have done something like this many, many times. It's just, after years of experience that I know what to look for when something, changes a variable, mysteriously. Then I look for stuff like this first. Okay, is that okay so far? What about the other ones, that you guys mentioned? What about Python? What about Perl? What about PHP? What do you think PHP will do? They will extend the array so that A bracket 3 now exists. Now that by itself is a huge problem too, especially with this program. Okay? Because what happens is Python or PHP will say, oh, okay, I'll do the right thing. I'm not just going to grab the mixed coffee mug and call it, A bracket 3. I'll actually make the box bigger. Yeah, now the box is bigger. Now we have coffee mug 3, and this is where the new box ends. Okay, so it's not going to do any corruption. Okay, there's no corruption going on because now you actually have the space of A bracket 3. A bracket 3. In other words, if I were to do it this way, column G is now a part of the coffee mug, and it's okay. Okay, it seems like everything is fine. I mean, so this guy gets a value of 8 inside. The value is representing is 8. What happens when we get back to line 3? What is bar A bar? Bar A bar is now 4. I is 4, bar A bar is also 4. 4 is less than or equal to 4 is true. In other words, this would become what we call an infinite loop until your computer runs out of memory. Because the box will get bigger and bigger and bigger until there's no space left on the shelf to add another item.
Yeah, but the thing about it, the Python lists are immutable. You can't change them. Like, once you make a list, it can't be changed.
I think you can.
It doesn't let you.
It doesn't let you?
Change a list in Python once it's already been made.
Okay, but in PHP, in Perl, this is what's going to happen. Does it automatically append? That's the question. Does it automatically extend a list or an array? Because in some languages they mean the same thing.
Dictionaries you can, and
But list.
Most scripting languages will automatically extend.
Dictionary you can add the keys and values.
But in any case, the result is probably not something that we intend, and that's why using a less than versus a less than or equal to is very important. Okay, it's actually important in this case whether it's just less than or equal to. Now you can use less than or equal to if you want to, but then you have to subtract 1 from bar A bar. Because that will still be safe, it's actually meaning the same thing as last time. But without a -1, the program is not going to do what it's supposed to do. Okay, well, we are running out of time. I'll let you guys go. So don't forget the homework assignment. On Tuesday, next Tuesday, we'll have our first practice test. If you are not in the class, you need to add to the class now. So just come here and I'll tell you what to do.